Welcome to this video. Uh, we are going to discuss question number 16, which came in JEE Advanced paper 2023. So we have a furnace whose diameter is 1 meter. It is maintained at temperature of 360 kelvins. Air gets heated inside the furnace at some constant pressure. So as the air is entering, its temperature is some 300 Kelvin and it gets heated to 360 Kelvin. So we can write an equation that PV is equal to nRT. So dividing this by the mass of the gas entering inside, we can write pressure upon density is equal to RT divided by molar mass of the gas. So this implies density into temperature is a constant. So basically, as air is entering inside, the density of the air is 1.2 kg per meter cube, and a temperature of the gas which is entering is 300 kelvins. Once it has reached this particular point, that it has traversed this small distance h in comparison to the height of the furnace, its density will become rho and temperature will become 360 kelvins. So this value rho will be equal to 1.2 into 3 by 3.6. So that is 1 kg per meter cube. So now further what is asked is what is the steady mass flow rate of air. So to calculate steady mass flow, we need three things: density, cross-section area, and the speed at which the air is flowing. So what we will do is that we will apply the equation of band forces on this section of the air within the chimney. We will say that band force is pushing this chimney's air upward with increasing speed. So whatever speed it is increasing, that will produce an acceleration, and by virtue of that acceleration it will have gained some speed v square, which is what we want to find, that what is the speed with which the air is exiting the chimney. So to find that, we will say what is the band force acting. The band force acting is density of air, the cross-section area of the chimney, let's say it's some small s, then we'll say the height of the chimney, let's say h. So this is the band force, and g. This band force will act against the gravitational force, which is rho sh into g, rho being the density of air inside the chimney. So this is what we have calculated. Density of air in the chimney is 1 kg per meter cube. This would be equal to density of air into, again, the mass of the air which we are dealing with, into the acceleration which it has produced. So this is some so we'll say so after calculating this yes, so then we'll say rho A minus rho so after all the calculation we'll get some acceleration, right? And after getting that acceleration we'll substitute that acceleration in the expression v square is equal to 2ah. The value of h we know, value of h is some 9 meters, and the value of acceleration would be I think some 2 meter per second square, something like that. So acceleration is 2 meter per second square, and the height of the chimney is 9. So it would be 2 into 2 into 9, that would be my v square. So we would come out to be some 6 meters per second. When we'll put the value 6 meter per second in our chimney, we'll get the mass flow rate. So mass flow rate is density into cross section area into the speed. So the cross section area of the chimney is some 0.1, right? That is the diameter of the chimney. So we'll say that the density of the chimney being 1 multiplied by the cross section area pi d square by 4 into the speed with which the fluid is traveling, that is 6 meter per second. So that would be 6 divided by 4, that is 1.5 times 3.14 into 0.01. So that would be 1.5 times 3.14, so it would be somewhat like 4.6 some value 4.6 times 0.01. So that is your value in kg per second, right? So 4.6 into 10 to the power minus 2, when we multiply that by 10 to the power 3, it would become 46 point something. So that is the value which we should get, 47 gram per second. So thank you for joining and have a good day.